This location 1120 to 120. Let's start with this 1120. That's the location of the grid block X1, Y1, and Z20. So maybe block properties 120. And what do you want to see? Let's see, guess more fraction of H2O. Okay, so you can see here. It will be great if you can see directly the injectivity, but I don't think so. Let's plot first gas rate. Okay, maybe delete. It's very short-lived actually, because we only inject 1 year. Yeah, I don't think, plotting the injectivity profile will be relevant for our case because we only inject in 1 year for 1 year. Okay, so we cannot practically see the injectivity profile. Okay, and let's see if permeability is changing. Just to confirm, I'm not sure, by the way, because once again, you have water vaporization, you will have salt precipitation, so the injectivity will drop. I just want to see whether there is change in permeability. But of course, we cannot have change in permeability if we, do not activate the geomechanics. And I don't think in this model we incorporate the geomechanical model. So just to check permeability in I direction, constant, right? And porosity also. If you include, the geomechanics and something like that, the porosity can be changed. The porosity can change. So let's see, just to confirm. Poro. Okay, you can see. Yeah. Why do we have porosity change here? So the porosity steady and then increases and then decreases. What about the effective? All right, the same. Yeah, because not only geomechanics actually, we now incorporate, mineralization. Okay, and in mineralization, you have salt precipitation, which will reduce your permeability, or first and foremost, can reduce your porosity. And if you activate the connectivity between permeability and porosity, it can also affect the permeability. Okay, but first it will influence the porosity, and it is reflected in our plot. Our porosity is not constant. Okay, our porosity is changing because we have mineralization and we also have water vaporization, which results in salt precipitation. Salt precipitation will reduce your porosity. That's why we have also porosity reduction here. Okay, so I think that's about it. That's all about water vaporization. Okay, so it's very, very interesting once again. Okay. All right, and maybe, yeah, just to check porosity. Let's see. You can see here, if I stick, you know, my position at a particular, particular grid block like this, let's see if across time, the permeability, or in this case, porosity, will change. I play. You can see the porosity changing, right? The porosity is not constant. The porosity at the same place keeps changing because porosity in this case with mineralization, with salt precipitation, with water vaporization, the porosity is not constant. Okay, so yeah, once again, if you want, I'm going to refresh the result and then let's see. Lastly, just to confirm our gas mole fraction. Okay, so wait a minute. Okay, so just lastly, just to check this one, display gas mole fraction of H2O. Okay, all right, so everything's good. Once again, you can see this, everything's good. Okay, so we have gas mole fraction of H2O, which means that H2O turns into gaseous phase, or actually the water, the H2O vaporize into a gaseous phase. Okay, so I think that's all. I hope you enjoyed this video. I hope this video is useful. Thank you so much for watching and see you again in the next CO2 sequestration modeling videos. Thank you.